You know, when you see a butterfly, it's easy to just see this beautiful, delicate thing flitting from flower to flower. But what if I told you that you're actually looking at a masterpiece of microengineering? Seriously, there's so much more going on than meets the eye.
So that really brings us to our big question, right? Is it just a pretty insect, or is it a highly sophisticated machine that's been hiding right in front of us this whole time? We're going to peel back the layers and uncover a secret that, believe it or not, scientists have only recently figured out.
All right, so before we get to the big reveal, we really need to understand the fundamental design here. Let's pop the hood, so to speak, and see how this amazing biological machine is actually put together.
Okay, so let's start with the basic blueprint. Like pretty much all insects, a butterfly is built on a modular design, one that's been refined over millions and millions of years of evolution, where every single part has a very specific job to do.
And this design is incredibly efficient. The body is broken down into 3 distinct sections. You've got the head, that's basically mission control, packed with all the sensory gear. Then there's the thorax, which is the engine room, powering the wings and the legs. And finally, the abdomen, which takes care of all the internal systems like digestion and reproduction. It's a perfect division of labor.
And of course, you can't talk about butterflies without talking about their insane life cycle. I mean, they go through complete metamorphosis, which is a total reinvention. It starts as a tiny egg, which hatches into a larva, or caterpillar, that is basically just an eating machine. Then it seals itself up in a chrysalis, and this is where the real magic happens. It pretty much turns to goo and completely rebuilds itself into the final stage, the adult butterfly. Okay, so we've got the basic body plan down. Now for the fun stuff. Let's explore the superpowers that really make a butterfly, well, a butterfly.
Their scientific name, Lepidoptera, actually gives us a massive clue. It comes from ancient Greek, and it literally means scale wing. And those tiny, tiny scales, they are the key to almost everything.
Yeah, these microscopic scales are so much more than just pretty decoration. They're multifunctional marvels. They act as insulation to help regulate body temperature, they improve aerodynamics in flight, they create patterns for camouflage or to warn off predators, and of course, they produce those absolutely breathtaking colors.
But here's what's going to blow your mind. The most vibrant colors, like that stunning shimmering blue on a morpho butterfly, they don't come from pigment at all. It's something called structural coloration. The scales have these microscopic crystal-like structures that bend and scatter light, reflecting only specific colors back to our eyes. It's pure physics, not chemistry. It's basically natural nanotechnology. You know, butterflies experience the world in a way that's totally alien to us. Their huge compound eyes give them this wide mosaic view of the world, and, get this, they can see ultraviolet light. This means flowers have secret patterns on them, like glowing landing strips that guide them right to the nectar. And their antennae are just as amazing. They're powerful chemical detectors. We're talking so sensitive that some male moths can smell a potential mate from more than a mile away. Just wild.
Okay, so we've covered the body, the wings, the incredible senses. But now we get to the central mystery of this whole thing. We all know butterflies drink nectar with that long curly tongue. But how does it actually work? I promise you, the answer is not what you think.
First off, that tongue is actually called a proboscis, and it is a remarkable piece of natural engineering. It's formed from 2 long tubes that literally zip together with tiny hooks to create a central drinking channel. When it's not being used, it coils up neatly right under the head.
Now, for over 100 years, the scientific consensus was pretty simple. The proboscis works just like a drinking straw. A pump in the butterfly's head creates suction, which pulls the nectar up the tube. It makes perfect sense, right? Or does it? So this is the old theory, the drinking straw model. The proboscis is just a simple, sealed tube. Liquid can only get in at the very tip, and then it has to be pulled all the way up. For decades, this was the accepted model. End of story. But what if that wasn't the full story? Well, recent research has completely overturned that century-old assumption, revealing a system that is far more elegant and way more efficient.
You see, scientists started to question this. Trying to pull a thick, sugary liquid like nectar up a really long, thin tube takes a lot of energy. And for an insect that has to be super efficient to survive, is that really the best design? It turns out nature found a much, much better way. And here is the answer: the permeable slit model. It turns out the proboscis isn't a sealed tube at all. Those little interlocking hooks that zip it together actually create tiny, permeable gaps all along its length. This means the butterfly can draw in liquid along the entire submerged part of its proboscis, all at the same time.
The difference in efficiency here is huge. Think of it like a drinking straw versus a soaker hose. The straw is slow, it takes a lot of energy to create suction, but the soaker hose, it just draws in liquid all along its surface, using passive capillary action. It is so much faster, uses way less energy, and it allows the butterfly to drink from really shallow films of moisture, not just deep pools of nectar.
So the butterfly's proboscis is less like a simple straw and way more like a high-tech soaker hose. And this isn't just a cool little detail. It has massive implications for how the butterfly actually survives.
This incredible design gives the butterfly 3 huge advantages. 1. Faster drinking means less time spent out in the open exposed to predators. 2. Relying on passive physics, capillary action, conserves precious energy. And 3. It dramatically expands the menu, allowing it to drink from dew on a leaf or even a thin film of juice on rotting fruit. It's a real game changer.
Ultimately, this discovery just shows us that nature's engineering is often far more subtle and brilliant than we first assume. We looked at a butterfly and saw a simple straw, but evolution had perfected this complex, super efficient system that was hiding in plain sight the entire time.
And that kind of leaves us with a final thought, doesn't it? For over 100 years, we thought we knew something as simple as how a butterfly drinks, and it took modern technology to show us the truth. It just makes you wonder. What other everyday marvels have we completely misunderstood? What other secrets is the natural world just waiting to reveal?